Hello once more. This is another video on straight line graphs, pure chapter 5.4 in fact, so the fourth lesson in on the topic of straight line graphs. So we're going to be taking our understanding a bit further and having a look at some worked examples, including a couple more real past paper examples. So let's get straight to it. So here are 4 warm-up questions for you to try. You should know the deal by now. Try them first. Use the video to see if you've got them right, and if not, use the video to help you make those necessary corrections. So let's get started on question 1. Question 1, we have to show that the line with equation 9x minus 2y plus 3 equals 0 is perpendicular to the line with equation 4x plus 18y minus 7 equals 0. What I'd suggest here is to take each one and rearrange it into the form y equals mx plus c. So I'm going to start by just taking 9x minus 2y plus 3 equals 0 and rearranging this by adding 2y to both sides. So we get 2y equals 9x plus 3. Then we divide through by 2. We get that y equals 9 over 2x plus 3 over 2. And so all we've done here is rearranged this first one in yellow into this standard y equals mx plus c form. We can now do the same with this one here. So I'm just going to rewrite it first of all as it is without changing anything and take it from there. So initially we have 4x plus 18y minus 7 equals 0. So if we leave the 18y on this side, subtract off 4x on both sides, and add 7. That gives us 18y equals minus 4x plus 7. We can now divide through everything by 18 to get y equals minus 4x over 18. Minus 4 and 18 we can divide through by 2, so simplify, that becomes minus 2 over 9x. Then plus 7 over 18. So again, not done much yet. All I've done is taken this one and rearranged it into the standard y equals mx plus c form. The next thing to consider is the gradients of both. So the gradient of this one here is 9 over 2, and the gradient of the second one is minus 2 over 9. What we need to recall now is that if two lines are perpendicular to one another, the product of their gradients equals minus 1. So if we just take both, that 9 over 2 and this minus 2 over 9 and multiply them together, we get 9 over 2 multiplied by minus 2 over 9. It's not too hard to see that that will give you minus 1. So therefore, the product of the gradients is equal to negative 1. So therefore, in other words, the lines are perpendicular. I think I'll put to each other as well, just for added clarity. I'm not sure if I needed to put that, it's probably clear enough, but I'll add it in anyway. That's question 1 sorted. Question 2, we have point A, which is minus 2p, we don't know what p is yet, and B, which is at 7/16. We're told the distance between A and B, the distance AB, is 5 root 10. Calculate the possible values of p. Now interestingly, it doesn't say calculate the value of p, it says possible values of p. So rather than thinking, well, where do I start, let's just go back to basics and just think about finding our value of what p might be. So we know we're dealing with a straight line. So what I'd suggest doing, not that we have to, but I'd strongly suggest just doing a sketch like this. So at one end we've got A, well, one possible A, and B, which is up here, which is 7/16. What we can do now is apply some Pythagoras. We can fairly easily make a right-angled triangle out of this by just considering the horizontal distance between the two and considering the vertical distance between the two. So one of these needs to be in terms of p. So in terms of p, what's the vertical distance between these 2 points? Well, this one's 16 and this one's p. So therefore it must be the case that the vertical distance between these has to be 16 minus p. In the same way, or the similar way, the horizontal distance, if one is minus 2 and the other point's 7, we can work out the distance between them by doing 7 minus 2, which is 7 plus 2, which is 9. And so we know that we can use Pythagoras to work out this distance here. If I call that, I don't know, let's just call it c, by doing c is a square root of this squared plus this squared, all of that square rooted. And so c, but actually we know what c is, don't we? So scrap that, just thought about this. C, the distance, we're told it's 5 root 10. Even better. So if we just apply Pythagoras to this scenario now, this side squared, the hypotenuse squared, is going to equal this side squared, 16 minus p all squared, plus the other shorter side, which is 9 squared. So 5 squared is 25, root 10 squared is 10. We're going to leave 16 minus p all squared as it is. So a common thing people might do is to expand all this out, but actually in this particular case it would make it harder. So I'm just going to leave this as 16 minus p all squared. Obviously 9 squared is 81. So if I make 16 minus p squared a subject and just make that first, 25 times 10 is 280, and then we can subtract 81 from both sides, so that gives us 169. We can now square root both sides, and so 16 minus p all squared becomes 16 minus p, and over here the square root of 169 is 13. But very importantly, when we square root both sides, if we have a constant, we need to consider plus or minus that constant. So therefore we can see p has 2 different values. So therefore p is going to be 16 minus 13, which is 3. And that seems right, doesn't it? So minus 2, 3. Minus 2 is to the left of 7, and 3 is below 16, so that looks right. However, this plus root gives us another option. And so another option is that p may equal 16 plus 13, which is 29. So we've done the question now, we don't need to worry about anything else, but I would like to consider that you might want to know the significance of this 29, the geometrical significance of this. So what you might want to think about now is just imagining this, the other point of A. So we know that A is on the line somewhere, which is on minus 2. Okay, so the x value for A is fixed at minus 2. So we've got the answers now, we're fine. Okay, so we've done the question now, I'm just talking you through why we have 2 different values. Well, the reason for that is we knew the x-coordinate of A was minus 2, so we knew the x-coordinate was less than the x-coordinate of b, so we knew a had to be to the left, but what we did is we took a guess on p being less than 16, hence point A being lower. For all we knew, point P may have been higher. And so the other alternative explanation is that A might have been higher. Okay, so we could have a case where A is higher up, like here. And so what we can think about is that this is A1, where P is 3, and up here, that's A2. That's a second option for A, where A would be minus 2, 29. So down here, A is minus 2, 3. Up here, the other option for A is minus 2, 29. And so this would be a isosceles triangle where both of these lines, both of these distances, would be equal to 5 root 10. And so that's why we have two different possibilities for the values of P. Next up, question 3. Find the coordinates of a point of intersection between the line y equals 3x plus 2 and the line 3x plus 2y minus 8 equals 0. Again, as ever with maths, there's almost always more than one way of tackling something, so what I'm going to suggest here might not be the way you go for. What I'm going to do here is I'm going to find out where they intersect by substituting in this expression for y from one equation into the second equation. So all I'm doing right now is just subbing in 3x plus 2 in place of y. That step now transforms this second equation into 3x plus 2 lots of 3x plus 2, because that's the expression for what y is, minus 8 equals 0. We can now neaten this up, expand it out and such, so we get 3x plus 2 times 3x is 6x, 2 times 2 is 4, and finally this minus 8 at the end. 3x plus 6x, that gives us 9x. 4 minus 8, that's minus 4. Therefore, we see that x must be 4 over 9. We can now substitute in for x is 4 over 9 into one of the initial equations, whichever is easiest, I would suggest. The top equation here looks more straightforward to me than the second one, so my suggestion would be to substitute in 4 over 9 into the first equation. So what we have there is that y must be equal to 3 lots of 4 over 9. 3x is 3 lots of 4 over 9 plus 2. And that gives us a value of 10 thirds. So therefore, the point of intersection is when x is 4/9 and y is 10 thirds. I only wish I could write faster. Apologies if you think I go a bit too slowly. Last but not least, question 4. Find the coordinates of the points of intersection, points plural, bear in mind, of y equals 2x minus 5 and y equals 4x plus 2. Note here, both are already in the form y equals, and so to find the points of intersection, we can just simply equate the expressions for y. And so we can set 2 over x minus 5 equal to the second expression for y, 4x plus 2. So, what we can do first of all is multiply both sides of this equation by x. It's actually quadratic. It doesn't look like it yet, but when we multiply through by x, we'll see that it is. So 2 over x multiplied by x just becomes 2. Minus 5 becomes minus 5x. 4x multiplied by x becomes 4x squared. And then 2 multiplied by x is obviously just 2x. If we add 5x and subtract 2 from both sides, we arrive at 4x squared plus 7x minus 2 equals 0. Next, what we need to do is use this AC method to factorise. So we need two numbers that multiply together to give -8. We get -8 by taking the 4 and multiplying by the -2. And so we can think of two numbers that multiply together to give -8, but when we add them up, gives us +7. We can think of those two numbers. I'll just make this a bit neater actually, if the pen's going a bit wonky. 7x. Two numbers that multiply to -8 and add up to +7, that's going to be +8 and -1. So we can partition this 7x into +8x minus 1x, and of course -2 equals 0. This now factorises into two different partitions. So 4x squared plus 8x, we can factorise out a 4 and an x from that, which gives us x plus 2. And minus x minus 2 has a common factor of -1. And so in the brackets goes x plus 2. So now we can put the 4x and the -1 into its own bracket. We have x plus 2 equals 0. So we can see here there's going to be two different roots. And so therefore, one root is when this one is equal to 0, this bracket. That'll happen when x is a quarter. Or it might be that this bracket is equal to 0. If that's equal to 0, x needs to be -2. But we didn't just want the roots here, we wanted the coordinates of the points of intersection. And so we need to find the y values as well for each value of x. So if x were a quarter, we can use this equation here because that's probably the easier one. So if x were a quarter, we're going to have that y is 4 times a quarter, and plus 2, which is going to be 3. So that's one coordinate. We now do the same considering what if x were -2. Well, if x were -2, y would be 4 times -2 plus 2, which would be -6. So that would probably please most examiners, if not all. But just to really just beat them around the head with it, I'm going to put this into coordinate form because it does ask for coordinates. So one option is x is a quarter and y is 3. The other option is x being -2 and y being -6. So let's just write this clear as day. The points of intersection are, well, the first one is a quarter and 3, and the second one is -2 and -6. And that concludes our glorious warm-up. We're now going to think about how we can work out the distance between two distinct points on a line. We've actually done this before, just by drawing diagrams and such, but I want to mention it in its own right. Okay, so it's something we can do using Pythagoras, but it's worth a mention in its own right, as I say. So let's just have a think and make it formal. So we can find the distance between 2 points, A and B, by considering a right-angled triangle with hypotenuse AB. Like I say, we've done it before using Pythagoras. This is just it. So there's a general straight line, there's a known point A and a known point B on the line. So we're going to call A x1, y1 and B x2, y2. And for distance between A and B, we're just going to call it D for distance. So first of all, we can see the horizontal distance between these two is going to be given by x2 minus x1. This yellow highlighted line I've added in here. In a similar way, the vertical distance is going to be the distance between the y-coordinate of B and the y-coordinate of A. So this distance here is going to be y2 minus y1, which I've added in here using green. So now we can apply Pythagoras. Now we've got expressions for all of these sides. So the distance between D, so the distance of D, which is between x1, y1 and x2, y2, is given by this formula here. D is the square root of this side all squared plus that side all squared. It's just Pythagoras. It looks more complicated because these expressions are harder than just a squared plus b squared. Okay? But all it is Pythagoras. So let's apply this with a simple worked example. So find the exact distance between the points 4, 11 and 10, 14. So don't need to do this, but I'm going to just do a straight line here just so we can see what's going on. So if I were to just do a point here on the line and there, I can call the lower point 4, 11 and the higher point, I can give it the coordinates 10, 14. Okay, so I could just use that formula I showed you earlier, but let's just think about it in terms of Pythagoras just for the sake of it. So we've got this distance here, and that distance vertically. So we can see, I'd hope, that the vertical distance between these 2 points is going to be 14 minus 11, which is going to be 3. The horizontal distance between these 2 points is 10 take away 4, which is going to be 6. If I just call that D for the distance, I could call it anything, could call it C in terms of A, B, C, Pythagoras, or I could just call it H, hypotenuse. Call it what you want as long as it's tasteful. So D, using Pythagoras, is just simply going to be the square root of 6 squared plus 3 squared. You can do this on the calculator, it'll give it you straight away. But let's just use our non-calculator skills if we can. So 6 squared is 36, 3 squared is 9. 36 plus 9, last time I checked, is 45. Let's just revise some surds, shall we? Let's see if we can simplify this. Is there a factor of 45 that's a square number? There is. We can split this up into root 9 and root 5 because, whoops, bit of a wobble there, because 9 times 5 is 45. But of course, because root 9 is 3, that just simply becomes 3 root 5. And that's as simple as we can go. If in doubt, give it in exact form. Don't give a decimal answer unless a question says to give your answer to a certain number of decimal places or significant figures. Exact form is often the best, especially in pure maths. Let's have a look at a real past paper worked example now. So this came up in the old spec. So this is putting together a few different skills we've come across up to this point. It's not just on what we're covering this lesson. Part A asks us to find an equation of the line joining A, which is 7, 4, and B, which is at 2, 0, giving the answer in the form ax plus by plus c equals 0, where a, b and c are integers. So to do this, what I'd suggest we might want to do first is to calculate the gradient. So the gradient between any 2 points is the change in y between these points. So let's do 0 minus 4. And divide that by the change in x between those 2 points. So that's going to be 2 minus 7. So the top's going to be minus 4, the bottom's going to be minus 5, minus 4 divided by minus 5. We can just call that 4/5. We also know 2 points, so we can pick any point, and then we could either use y minus y1 equals m brackets x minus x1, or we can go for the old fantastic y equals mx plus c, and substitute in a known y and a known x. We know the gradient now is 4/5, so we can sub this in. I'd suggest going for 2, 0, because it's just the easiest point. So we know that when x is 2, y is 0. So let's just substitute in what we know. So 0 equals m times x, which is 2. So again, just going to highlight what we know. Gradient was 4/5. We knew y was 0 when x was 2. And of course we need to put on plus c. So rearrange that, we get that therefore c has to be minus 8/5. So y equals mx plus c actually becomes y equals 4/5 x minus 8/5. It'd be tempting to think we're done because we have an equation of this line. However, we need it in this particular form. So what I'm going to suggest we might want to do is to get rid of these denominators by multiplying all sides by 5. So the left-hand side, after I've multiplied by 5, is going to become 5y. This is going to become 4x. And minus 8 over 5 becomes minus 8. And a very simple rearrangement, if we just subtract 5y from both sides, we get, therefore, 4x minus 5y minus 8 equals 0. And that's part A completed. Part B, it asks us to find the length of AB, leaving our answer in third form. So for this one, let's just remind ourselves of what A was and what B is. So this is using what we talked about earlier, finding the distance between 2 points. So if you want to, I invite you to draw a diagram, or you can just use that formula I mentioned. So I'm going to just go for the formula. Be my guest if you want to draw a diagram, nothing wrong with doing that at all. So from A to B, that's going to be the square root of the distance in between the x coordinates. So the difference in between 7 and 2 is 5. The difference in between the y coordinates, between 4 and 0, that's just 4. So AB is going to be 5 squared plus 4 squared. 5 squared is 25, 4 squared is 16, so AB is 25 plus 16. In other words, AB is root 41, and leave it in exact form. For part C, we're told that point C has coordinates 2 and t, where t is greater than 0, and where AC equals AB. Find the value of t. Now, this here, there's quite a lot going off. We've got AC equals AB, we've got a coordinate where we're not sure where it lies. It's a lot to visualise, so what I'd strongly suggest for this one would be to map out this on a carefully sketched diagram. So my suggestion would be to start off as follows. Get any sort of obvious looking line. I wouldn't say do it completely vertical or completely horizontal. Do the line with a slope at least. Label on what we know on this line. And so we know A is 0.74. We also know that B is the 0.20. We also are told that this point C has coordinates 2t. So we don't know what t is, but we know the x coordinate is 2. So we know that C is going to either be directly above or directly below B, because B shares the same x coordinate as this one here. So C is either going to be down here or up there. So in other words, C is going to be somewhere along this dotted line. Another thing we're told, though, is wherever C is, the distance from A to C has to be the distance from A to B as well. So in other words, if we were to do a triangle, the side AB would have to be the same length as the side from A to C. And so ABC would have to be an isosceles triangle with two sides equal, these sides equal. So that tells us that C has to be somewhere up here. C is going to be here, and AC, this side, is the same as AB, which is this side. Okay, so that's how the sketch and just building it up step by step can really help us out. So AC is this one, and we're told that's the same as AB, which is this side here. So now we can find the value of t fairly easily. In fact, what we could do is just add a bit more information onto this. If it's not clear enough already, it probably is. So because this is an isosceles triangle, it's going to have a line of symmetry down the middle. So it's going to have a line of symmetry here. And so let's just think about the distances between these points. So if we think about going from B up to this point here, the y-coordinate goes from 0 up to 4. And so this distance must be 4. And then by symmetry, or just thinking about it logically really, if that's 4, this has to be 4 as well, doesn't it? Because again, this is the line of symmetry on this isosceles triangle. And so C from B, we're adding 4 plus 4, we're adding 8 in total in the y direction. And so that tells us that T must be this 4 plus that 4. In other words, T has to be 8. For D, find the area of triangle ABC. So if I just return to a version of the sketch we had from part C, we had this. Okay, so let's label on what we had from before. So from before, what we had is we knew that this distance here from B to C was a distance of 8. So let's label this on once again. We can also work out fairly easily what this distance here is, the perpendicular height of a triangle, by just comparing the x-coordinates. Okay, so this distance was 8. Then from here to there, from B or C to A, what's x changing by? Well, the x-coordinate here is 2. Moving along up to this point, it goes to 7. And so the distance in the x direction moving along is 7 minus 2. This height must be 5. So we now can just apply the formula for the area of a triangle, which we probably know off heart from GCSE. I hope you'd know it off heart anyway. So the area of ABC is just going to be half times base times height, or BH over 2, whichever way you want to use and remember it. So that's half times the base, which is 8, times the perpendicular height, which we've got is 5. 8 times 5 is 40. Half of 40 is 20. We're not told of units in this question, so let's just leave this as 20 units squared. In fact, the examiner would almost definitely let you off if you just put equals 20 without mentioning any units, but it doesn't hurt just to put that you're aware it's an area, so you're just making reference to the fact you've worked out an area by just putting in the generic units squared. Lastly, we finish by looking at another worked example from a past paper, which I've rather unimaginatively called past paper worked example 2. So we've got this diagram to begin with. We've got points Q, which is 1, 3, and R, which is 7, 0, lying on the line L1, as shown in figure 1 opposite. We're told that the length of QR is a root 5, and we need to find the value of a. So this is an application of the distance in between 2 points formula. We know what QR is, so one thing we could do is just apply the formula directly. Just to help out matters, I'm just going to make it a bit more visual. In fact, I won't have a double-headed arrow. What I'll have is just a dotted line going down from Q to the x-axis. And so we know that Q is 1, 3, so we can label that in. So the y-coordinate of Q is 3, the y-coordinate of the x-axis is obviously 0, so this distance here has to be 3. And more than that, if I were to think about the distance from R to this point here, the bottom of where Q is, well, R is at 7 on the x-axis, Q is at the point 1 on the x-axis, so 7 minus 1, this distance here must be 6. So in other words, QR, which is a root 5, must be the square root of 3 squared plus 6 squared. So if we just evaluate this, 3 squared is 9, 6 squared is 36. So we have a square root of 45. This is very similar to an example we did earlier, in fact, if you remember that, in this lesson. So a square number that's a factor of 45, well, we can realise that that number's 9. So we can split 45 into 9 and 5. And root 9 is obviously 3. So now we've got it as we want it. So QR is in the form a root 5. We've got 3 root 5. Therefore, obviously, a must be 3. So we just need to write that down to make it clear to the examiner that we know that a is therefore 3. Part B, I've just filled in some of the information we now know from Part A. So we knew Q and we knew R already, and L1 from Q to R at least is 3 root 5. We're now told about this line L2. We're told two things. We're told it's perpendicular to L1, and we're also told it passes through Q. We also now need to find out what the y-coordinate is afterwards, where it crosses the y-axis. But first of all, using these two things, that it's perpendicular to L1 and passes through Q, we need to find an equation of L2. Okay, so first of all, we need to work out the gradient of L1, then from that, we can work out the gradient of L2. So the gradient of L1 is the change in y between Q and R, and so y goes from 3 down to 0, so the change in y is 0 minus 3, y goes 3 down, and the change in x goes from 1 up to 7, and so x goes along by 7 take away 1, which is 6. So therefore the gradient of L1 is minus 3 over 6, which obviously is just minus a half. So therefore, because L2 is perpendicular to L1, the gradient of L2 is going to be the negative reciprocal minus 1 over the gradient of L1. So it's going to be minus 1 over minus a half. The minuses will effectively cancel. So we get 1 divided by a half, which is 2. So we know the gradient of L2 is 2. We're also told that it passes through Q. So using that, we can use this form of the equation. We can do y minus y1 equals m, brackets, x minus x1. In effect, we could have also done the standard y equals mx plus c. But now we know what the gradient is. The gradient we know is 2 for line L2. Knowing that it passes through Q, we know a known y-coordinate on the line L2 is 3, and we also know a known x-coordinate, because it passes through Q, is 1. So just substituting in these values here, we have y minus 3 equals 2 brackets x minus 1. Now if you have a look at the question, how it's been worded, it just says find an equation for L2. It doesn't say it has to be written in y equals mx plus c or ax plus by plus c equals 0, just an equation. So that would actually be fine. You could leave it like that and get full marks. Alternatively, you may have wanted to rearrange into something more familiar, like y equals mx plus c. So if you wanted to rearrange this into y equals mx plus c, we could take it expanded out of the brackets to get 2x minus 2, then added 3 to both sides to get y equals 2x plus 1. So either one or the other would have been fine, either this one or that one. Part C, we need to work out the coordinates of P. So using what we had from before, from part B, we need to just remind ourselves of the equation of line L2. So I don't know about you, I'm more of a yx plus c person, always have, probably because I've just taught it from an earlier age, and I'm biased. So the coordinates of P, we know that at P, x is 0, so we can just sub in x equals 0 and generate the y-intercept. It's as simple as that. And so when x is 0, y is going to be 2 times 0 plus 1. So P must be 0, 1. In other words, i.e., P is the point 0, 1. And lastly, part D, we need to work out the area of the triangle PQR. So we were told that L2 is perpendicular to L1. So we can use that fact and realise that because it's perpendicular, what we have here is actually a right-angled triangle. So because it's a right-angled triangle, we can work out the area by doing half base times height. In other words, half one side multiplied by the other perpendicular side. So we can take half times QR times this side here, which is QP. Okay, from before, we worked out what QR was, if you remember. If you're not, just go back to the earlier part of the question. We knew that QR, we worked out that QR was 3 root 5. What we haven't done yet, though, is worked out what QP is. But we can do this simply enough. So if I just move to one side and just think about what QP is. Again, we can use that distance between 2 points formula. So between Q and P, let's just think about the change in the x-coordinates. So at P, x is 0. At Q, x is 1. So the change between 0 and 1 is obviously just 1. So we put 1 squared. Then we add to that the difference in the y-coordinates squared. So y goes from 1 at P to 3 at Q. So the difference in the y-coordinates is 3 minus 1, which is 2. And so QP is a square root of 1 squared plus 2 squared. In other words, QP is root 5. So now we know that, we can substitute this in. So QP is root 5, because we've now worked out what QP was. So now, we've got it more or less. We just need to simplify this and neaten up the third parts. So a half multiplied by 3 is 3 halves. Root 5 times another root 5 is just 5. So 3 halves times 5, that's 15 halves. So we can leave it like this and we're done. So we can say 15 over 2 units squared. Or if we wanted to give it as a decimal, 15 divided by 2 is 7.5. So we could have said the area of this triangle, equally valid, is 7.5 units squared. Whatever those units were or are, we're not told. And that's all from me. So now it's up to you to try for yourself. If you go to page 102, exercise 5G, and try questions 1, A, B, C, questions 4, 5, 6 and 7, and the later ones are put in red because they're a bit more of a challenge, 9, 10, 11 and 12. That should keep you very busy indeed. Try your best, keep working hard, check your answers using the back. If you get stuck, ask, please ask. Do not just hide your head under somewhere and just hope your problems will go away. Maths is unforgiving. Okay, you need all the help you get sometimes. So carry on doing what you're doing if you're working hard, and be in touch if you have any troubles. Thanks for listening to this video. Hope you got to the end. If you did, well done. I'll hopefully see you all soon. Bye for now.